Welcome to E-Chemistry class presented by Fatima Convent High School. Myself, Dipali. Let us continue Chapter 1 Chemical Reaction and Equation further. Just a quick recap of what we studied in the previous video. In the previous video, we studied about the difference between physical and chemical change. We studied that how chemical change and chemical equations are related. We studied various activities showing us chemical changes, and we understood that a chemical change occurs when there is a change in state, change in color, evolution of gas, or change in temperature, which is also a change in chemical reaction. We learned how to symbolically write the chemical reactions as chemical equations in word form and in symbolic form. We learned how to balance the chemical equation and learned how to get a balanced chemical equation with various states. Chemical equation and balancing chemical equation needs lots of practice, which we will do at the end of the lectures. Now let us move further with the chapter and study types of chemical reactions. Now in class 9th, we have learnt in class 9th that during a chemical reaction, the atoms of elements do not change into those of another elements, nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reaction involves breaking and making of bonds between atoms or produces new substances. We will study about types of bonds formed during chemical reaction between atoms in chapter 3 and 4. Yet, just for your knowledge, let us know that a chemical bonds are of two types. The two types of chemical bond are covalent bond and ionic bond. Now let us see the first type of chemical reaction, that is combination reaction. Let us perform an activity to understand what is combination reaction. Take a small amount of calcium oxide, which is symbolically denoted as CaO or quicklime, in a beaker. Slowly add water to this H2O. Touch the beaker as shown in the figure 1.3. Do you feel any change in temperature? Yes, you will feel the change in temperature. You will find that the beaker has become warmer. Now calcium oxide reacts vigorously with water to produce slake lime, that is also called as calcium hydroxide, releasing a large amount of heat. Calcium oxide, quicklime, H2O, they are the reactants here which combine to give CaOH twice in aqueous form, which is slake lime. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactant is known as a combination reaction. In general, we can denote this as, say, our reactants are represented by A and B and gives a product AB. So here one reactant combines with other reactant and gives a combined product, a single product. It is called as a combination reaction. A solution of slaked lime produced by the reaction 1.13 is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 or 3 days of whitewashing and gives a shiny finish to the wall. It is interesting to note that the chemical formula for marble is also CaCO3, that is calcium carbonate. So CaOH twice aqueous plus CO2 aqueous gives CaCO3 calcium carbonate plus H2O. This also is a kind of reaction about which we will study further in the chapter. There are few more examples related to combination reaction. Let us go through them. Let us discuss some more examples for chemical reaction. Burning of coal. Coal is pure carbon C plus oxygen, because it is burning in air, gives CO2. So here we have the product as AB, which is produced from reactant A plus reactant B, gives AB. So it is also a combination reaction. Formation of water from H2 and O2 gas. So 2H2 gas plus O2 gives 2H2O. So A plus B gives AB. Again, this is a combination reaction. In simple language, we can say that when two or more substances, elements or compounds combine to form a single product, the reaction is called as combination reaction. In activity 1.4, we also observed that a large amount of heat is evolved. This makes the reaction mixture warm. Reaction in which heat is released along with the formation of product is called as exothermic reaction. It's very easy to remember this word. There are two types of reaction based on the release of heat. They are endothermic and exothermic. Exo means out and thermic means heat. So when heat is given out, it is called as exothermic. And endo means in and thermic means heat. So endothermic, when heat is taken in, it is called as endothermic reaction. Other examples of exothermic reactions are burning of natural gas. CH4 gas plus 2O2 gives CO2 plus 2H2O. CH4 is methane gas, which is also called as natural gas, plus oxygen gives carbon dioxide and water. This is an example of exothermic reaction because heat is released during this equation. Do you know that respiration is an exothermic process? Yes. We all know that we need energy to stay alive. We get this energy from food we eat. During digestion, food is broken down into simpler substances. For example, rice, potato and bread contains carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cell of our body and provides energy. The special name of this reaction is respiration, and the process by which it is carried out will be studied in chapter 6. So the equation can be written as C6H12O6, that is glucose, plus 6O2 in aqueous state gives 6CO2 plus 6H2O plus energy. So it is an exothermic reaction. The decomposition of vegetable matter into compost is also an example of exothermic reaction. Identify the type of reaction taking place in activity 1.1 where heat is given out along with the formation of single product. So it is a exothermic reaction along with combination reaction. So till now we studied two kinds of reactions. They are combination reaction and exothermic reaction. Combination reaction in general is written as A plus B gives AB. An exothermic reaction can be represented as delta and upwards arrow. These symbols has importance in writing any chemical reactions. Delta represents heat and upwards arrow represents liberated. Or released. Now let us see one more type of chemical reaction, that is decomposition reaction. You can say decomposition reaction is reverse of combination reaction. Let us perform an activity. Take about 2 grams of ferrous sulfate, that is FeSO4 crystals, in a dry boiling tube. Note the color of the ferrous sulfate crystals. Heat the boiling tube over the flame of a burner or spirit lamp as shown in the figure. Observe the color of the crystal after heating. Have you noticed that the green color of ferrous sulfate crystal has changed? You can also smell the characteristic odor of burning sulfur. So, 2FeSO4 solid on heating gives Fe2O3 solid plus SO2 gas plus SO3 gas. In this reaction, you can observe that a single reactant breaks down, giving simpler compounds. This is decomposition reaction. Ferrous sulfate crystals FeSO4 7H2O lose water which react with heat and color of crystal changes. It then decomposes to ferric oxide Fe2O3, sulfur dioxide SO2 and sulfur trioxide SO3. Ferric oxide is a solid while SO2 and SO3 are gas. So, you will be able to understand how one single product, that is a reactant, broke down into 3 different products. This is a decomposition reaction. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime. It has many uses. One is in the manufacturing of cement. When a decomposition reaction is carried out by heating, it is called thermal decomposition. So, CaCO3 on heating gives CaO plus CO2. Another example of thermal decomposition reaction is given in the activity. Take about 2 grams lead nitrate powder in a boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame, as shown in the figure. What do you observe? Note down the change, if any. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide NO2, and the reaction that takes place is 2PbNO3 twice solid, that is lead nitrate, on heating gives 2PbO solid lead oxide plus 4NO2 nitrogen dioxide plus oxygen. Let us perform some more decomposition reaction as given in activity 1.7 and 1.8. This is very important topic about electrolysis of water. You can see the diagram. In the diagram, there is a glass tumbler. In the glass tumbler, they have fixed. You can use a plastic mug as well or a glass tumbler as well. In the plastic tumbler, they have fixed two terminals. They are the graphite rods which are attached to the positive and the negative terminals, anode and cathode, and a switch and a battery. So, an electric current is made to pass through this. Because of the passage of electric current, the water molecule dissociates and breaks into hydrogen gas and oxygen gas. So at one point, at one test tube, you will get oxygen, and the other test tube, you will get hydrogen. And this process is called electrolysis of water because the breaking of water molecule occurs with the help of electricity. Now let us see exactly how it works. Take a plastic mug, drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in this rubber stopper. Graphite is an allotrope of carbon. Connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of sulfuric acid to the water. Take 2 test tubes filled with water and insert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tube. Is the volume of gas collected the same in both the test tubes? Once the test tubes are filled with the respective gases, remove them carefully. Test these gases one by bringing a burning candle close to the mouth of the test tube. This step must be performed carefully by the teacher. What happens in each case? Which gas is present in each test tube? You will observe that the test tube which is having hydrogen will burn with a pop-up sound, and the test tube having oxygen, the flame will become brighter because oxygen helps in further burning. We take an example of another activity. Take 2 grams silver chloride in a china dish. What is its color? Place this china dish in sunlight for some time. Observe the color of silver chloride after some time. You will see that white colored silver chloride turns grey in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. Because here light is used, it is called as photo decomposition also. Silver bromide also behaves in the same way. 2 AgBr gives, in presence of sunlight, 2 Ag plus Br2. Like 2 AgCl in presence of sunlight gives 2 Ag plus Cl2. The above reactions are used in black and white photography. Which form of energy is causing this decomposition reaction? We have seen that decomposition reaction requires energy either in form of heat, light or electricity for breaking down the reactants. Reaction in which energy is absorbed are known as endothermic reactions. So, Now carry out the following activity. Take 2 grams of barium hydroxide in a test tube. Add 1 gram of ammonium chloride and mix with the help of a glass rod. Touch the bottom of the test tube with your palm. What do you feel? Is this an exothermic or endothermic reaction? It's an endothermic reaction. You will find that the test tube has become cold, or the test tube is having few droplets of water around it. This shows that the heat is being released, is being absorbed. The heat is being absorbed. This shows that it is an endothermic reaction. So, till now we studied the following reactions. Combination reaction, A plus B gives AB. Decomposition, that is AB gives A plus B. So can you see it? They are both opposite to each other. Now the decomposition reaction are of 3 main types. They are thermal decomposition, photo decomposition, or electric decomposition. And on the basis of heat, there are 2 types of reactions, that is endothermic and exothermic. So here we summarize this topic and see you soon with the next video with next topic. Thank you.